System Design Day 3. Let me open up. That's my system design. His name is Clubman, and he's a legend. My god, the book is so lovely. It's here. I think last time we were trying to fill the Notion page at the same time. Um, Let me do for half an hour. You can see my screen, right? Yeah. So where are we in the chapter one? I think we were just discussing about raw CPUs just in the starting point. Book is journey through both principles of practicalities. Okay. Typically think very different tools, but they are similar. Store data for some time. They have very different access patterns, which means different performance characteristics, and thus very different implementation. So basically, the access patterns are different for different systems or different data storage systems. Many new tools have emerged. They're optimized for a variety of different use cases. They no longer fit into traditional categories. Okay. So these days, Redis can be used for message queues or hmm, there are like database durability guarantees with Apache Kafka. Secondly, increasingly many applications now have such demanding or wide-ranging requirements that a single tool can no longer meet all of its data processing and storage needs. Instead, the work is broken down into tasks that can be performed efficiently on a single tool, and those different tools are stuck together using application code. That makes sense. Okay. If you, for example, if you have an application managed caching layer using memcached or similar, and a full text search server such as Elasticsearch or Solr separate from your main database, it's normally the application code's responsibility to keep those caches and indexes in sync with the main database. Figure 1.1 gives a glimpse of what this may look like. Okay, client requests, read requests, in-memory cache misses, and writes search requests. Okay, this makes sense. So whenever client request comes in, if it's an asynchronous task, it's sent to a message queue and they are handled asynchronously. When there's a search request, it will see the search use full text index. If it's already in cache, read it directly. Otherwise, invalidate or update cache. Cache misses and write primary database. Capture changes to data. Update search index. Probably I'm not very comfortable with search, how Solar works or Elasticsearch works, but that's a later issue. When you combine several tools in order to provide a service, the service interface or application programming interface usually hides those implementation details from clients. Now you have essentially created a new special purpose data from smaller general purpose components. The composite data system may provide certain guarantees that the cache will be correctly invalidated or updated on writes so that outside clients see consistent results. You're now not only an application developer but also a data system designer. Okay. If you're a designing a system or service, a lot of tricky questions arise. How do you ensure that the data remains correct and complete even when things go wrong internally? How do you provide consistently good performance to the clients even when parts of your system are degraded? How do you scale to handle an increase in load? What does a good API service look like? I think this is important. So, what questions should I ask myself? Should I answer myself when designing a data system? Um, I think I can type it. How do you ensure the data remains correct and complete even when things go wrong internally? Degraded. How do you scale to handle an increase in load? What does a good API for the service look like? Okay, including the skills and experience of the people involved, legacy system dependencies, the time scale for your delivery, your organization's tolerance, different kinds of risk, regulatory constraints, etc. These factors depend very much on the situation. In this book, we focus on they already write three concerns that are important in most software systems. Three concerns: reliability, scalability, and maintainability. Reliability is the system should work correctly even when there are faults. The faults can be hardware or software or even human errors. I think it's better. What is reliability? The system should continue to work correctly. What happens if I copy paste? Can I copy paste? I think it's better for me to type it. It's better to type without saying that. Um, but then I don't want to performing the correct function at the desired level of performance. Okay, the important things to note are at correctly, even in the face of adversity. Mm, hardware or software or human faults for what is scalability as a system grows, data volume, traffic volume, or complexity. What is scalability? The system grows. Maybe reasonable is reasonable important. Okay. Important thing is it can be a data volume or traffic volume or complexity of the system. We often miss complexity of the system blowing up. What's maintainability? It's basically making sure that different people work in the system, making sure that your code is adaptable for new use cases. Uh, Productivity of the existing database split across. I think I often suck at this, but I'm going to learn this. Really? Fine. Okay, we're going to think more about these topics in this chapter. In the following chapters, we'll look at algorithms, architectures to achieve these. Okay. Everybody has an intuitive idea what it means for software. For software, typical expectations include I think I should have some goals each day to complete at least this much. So today, what can I complete today? I think I can complete the reliability part. Okay, let's deal with this. Um, Everybody has an intuitive what it means. For software, typical expectations include functions performs the function that the user expected, can tolerate making mistakes and using the software in unexpected ways. Example of that would be searching for some illegal sites. What should it return? Is that a good example? Um, yeah, basically, but that might come under security. Mhm. So what if user clicks on something that they're not supposed to click? Or what if user sends, uh, let's say for LLMs, there's a context length which it can tolerate. What if user sends a text that is more than the context length? How will the software react? If its performance is good enough for the required use case under the expected load and data volume? Okay, so the main thing is its performances should be good enough for the expected data volume and load. The system prevents any unauthorized access and abuse. But this looks like security issue. Still, it's fine. It should not be prone to attacks. What are the expectations for reliability for software? Typical expectations include the application performs function that is expected. It can tolerate the making mistakes or using the software in unexpected ways. Expected lower and data volume. For this, we thought of LLMs with user inputting more context length than expected. How to solve this? You can either truncate or truncate or chunk their user input and reduce it somehow. Okay, all those things mean working correctly, then we can understand roughly continue to work correctly even when things go wrong. Wow, 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 wow. Typical expectations of reliability. I mean, I must. Is it like, can we draw parallels to humans? Do we work correctly even when things go wrong? At least I don't know. I work okay, not too bad when things are going wrong with me. But we as humans, do we do something? Let's say things are going wrong, uh, like you had an accident, and do you still perform what you want to? First of all, what do I want? Um, I don't know. I want to build something at scale. That's why I'm reading this book. But at the same time, I often waste my time in other deviations. Thing is, maybe I'm not so reliable, but I'm developing myself to become a reliable person, not for others, but for myself. Um, what am I doing for that? Things like this. I'm recording myself where I'm forced to, or I mean, I love to do this as well, but I'm forced to maintain a cadence of videos showing that I'm reliable. Mm-hmm. Okay, so my goal is to build something at scale. Um, so for that, I know I don't want to be a pussy. I need to be aggressive. I know that being aggressive means jumping on things, working hard or smart, um, ignoring your fears. But do systems have fear? Mm, I don't know. Jumping at things, improving step by step, either rapidly or slowly, but there is a positive movement, not movement, movement. Hum. Okay. So I think maintaining a cadence of 2 pages, is that good enough? What do you think? Um, Maybe not. I think cadence should be in time. Sometimes 2 pages take longer, sometimes shorter. Is it the work delivered or time spent to work for the delivery of the work, which is more important? Hmm, I think both are equally important, but at least 5 minutes cadence is very important. Um, since I am exposed to public, um, and I want this to be successful, so I should maintain a longer one. At the same time, I'm okay with failing while trying this. Um, okay, that sounds good. That sounds like a monologue, but it is a monologue. Hmm. Okay, things can go wrong are called faults. Systems can anticipate faults and cope with them, called fault tolerant or resilient. Um, I think, like me, I can sense something is wrong beforehand and can avoid that, not avoid, or cope with them. Hmm. Okay, this feels uncomfortable, but okay, let me. Feels uncomfortable, but it's how I grow. So, this is what I should do, even though it feels uncomfortable as an introvert. As in, what feels uncomfortable is that exposing myself. Um, when I mean, I have huge. What do we say that inferior complexity? Is that it? Not really, but um, I feel that people are judging me all the time, even though no one cares, or if they care as well. I don't. I want to be feeling okay. Let them judge. So what? I'm just myself. That's what is more important for me. But this is yeah. This is the path to go to achieve that. My mindset, my true mindset. Okay. Fault tolerant or resilient is systems that anticipate. So basically, you can anticipate that um, to maintain a copy of data so that if the first data volume fails or loses connectivity, you have another volume, maybe in a different zone, availability zone, so that you have a replica of data. Of course, it comes at a cost. You need to maintain the other data as well and have sync between them. Systems that anticipate faults and can cope with them. Of course, it's not possible to predict all types of faults ahead of your time, but I think it's a good idea for humans as well to write what kind of faults are like from external world or people. Like, let's say I get hurt often by hitting the edge of a bed frame. So is it possible to avoid that somehow, like beforehand, while setting up a house? Or let's say you know what other person thinks like, so you can expect what they are going to say, and you can keep the conversation um, according to your like common likes rather than speaking about what you like. That's that's a fault tolerant. If you talk about something which there's no common like, or where they are not interested in, or where you are not interested in, so that's like a failure of communication. Okay, it's good. I'm trying to relate human society to computer systems. Wow, I'm a genius. Good luck with getting the budget item approved. It only makes sense to talk about tolerating certain types of faults. Yeah, of course, you can't tolerate. I mean, anything can happen at any time, but it's being cautious about some types of faults. Can we categorize the faults we face? Um, yeah, maybe. I think I'm not doing reinforcement learning well. That I do some mistakes, but I repeat them often without learning anything. So my whatever alpha is so less. It's fine. A fault is usually defined as one component of the system deviating from its spec, whereas a failure is when the system as a whole stops providing required services to the user. Okay, fault versus failure. It's very important. And let me copy this. Fault versus failure. Fault is just one component of the system going down. Failure is fault is just your one of the kidneys is not functional, but still you survive. Failure is both of your kidneys go away. I think you can still survive with artificial dialysis, whatever. But what if entire body goes non-functional? Who knows? Uh, one component, the system deviating from its spec. Failure system also stops providing required service to the user. Faults can lead to failure, like one of your kidney getting worse might affect other kidney as well, and your entire human body as a whole. Hmm. Okay. That's all for today. I'm here, so we can continue from here tomorrow. See ya.